Hey guys, just to let you know that you can catch these lessons live every Thursday from 6 PM until 7 PM UK or BST time, and that will just allow you to ask any questions that you want and get some answers to them. Without further ado, let's get on with the lesson.
Okay, welcome back to the fifth free A-level maths tuition lesson live on YouTube. So today we're going to be covering a topic that hopefully is kind of short and kind of relatively easy, which is quadratic inequalities and simultaneous equations. Now, while I say it's a bit easy, some of the exam questions can ask you to do some pretty strange stuff with it, where you will be basically solving this, but you'll also be it'll be applied in a situation they might not be familiar with. For example, it could be an equation of a line passing through a circle, for example, and then you have to do all kinds of weird, wacky stuff. So let's get into kind of the basics. So this will follow on from what we were doing last week. So it just says solve the inequality x squared plus 8x is greater than 20. Okay? Now, all we're going to be doing here is solving the expression just like we did last week. So to do that, we need to make sure 0 is on one side. So if we subtract 20, we have x squared plus 8x minus 20 is greater than 0. And now we're just solving a regular quadratic. So we were looking for two numbers that times to minus 20, add to 8. That would be minus 10 and 2. So then our two brackets are just x minus 10, x plus 2 is greater than 0. So again, we're just doing quadratic inequalities at the moment. So we're starting off with something that's relatively basic, and then all we're doing is solving this as if this said equals 0. Okay, so you have x minus 10 has to equal 0, or x plus 2 equals 0. So x is either equal to 10, or x is equal to minus 2. And now, of course, the question is, we have an inequality, right? Not an equal sign. So it can't be equals. Okay, it has to have some kind of inequality, but how can we tell what it actually looks like? Well, what we do is we actually have a sketch of the graph. So if I just draw this, we know that it crosses at x equals minus 2 and x equals 10. Right, that's what this tells me right here. Now, since it's a positive quadratic, it's going to look like a happy face. Oh, that's terrible. Anyways, okay. Now, we look at this inequality. We're looking for all of the values greater than 0, which means all of the values above the x-axis, which is those two sides, which happens when x is greater than 10 or x is less than minus 2. So the answer here is going to be x is greater than 10 and or whichever word you want to use, x is less than minus 2. Okay? But keep in mind that a lot of the time what happens in exams is that students will forget kind of how to work this out. Okay, so they'll just kind of guess. So what they tend to write every single time is minus 2, x, and 10, which in this case is wrong, but in a lot of cases is right. So you need to know when it's right and when it's wrong, otherwise you drop a mark for no real reason. Okay, so hopefully that's all good. The next thing, it says find the set of values for x which satisfy both inequalities. This is going to be really important when you come on to do statistics and you do the binomial distribution. We already have the solutions for this first one. X squared plus 8x is greater than 20. So I don't need to do anything. But the second one, which is 18 plus 3x, is less than 23 plus x. That's slightly more interesting. We have to actually do something with that. So what we're going to do is bring all the x's to one side, so minus x from both sides, and we get 18 plus 2x is less than 23. Subtract 18 from both sides, we get 2x is less than 5. Divide by 2, and we get x is less than 5 over 2, or 2.5. Now, we want the values of x which satisfy both equations. So both of them have to be true at the same time. So some of you may be able to just look and see what the answer is going to be. So we have x is less than 2.5, and we also have x is greater than 10, or and whichever one you want to use. X is less than minus 2. Okay, so here's what I'm going to do. I'm going to draw a number line. Okay, so if we draw a number line, we don't need to be super detailed about it, right? So if we go just from -1, you technically don't need all of the numbers, but I'm going to use all of the numbers just for now, just so you can see what we're doing. So a number line from -2 to 10. Cool. So if you want x is greater than -2, that's going to be all of these values going to the right. Okay? And it's not a filled in circle because it's not equals to. X is greater than 10. Oh, sorry, I've actually done that completely incorrectly. So if I continue this off into infinity, that's the x is less than -2. If the x is greater than 10, we have all of those values here. Okay? Now, for the x is less than 2.5, what we're going to do is go here and draw a line going all the way to the left. And what we're looking for is the parts where this overlaps with each other. So, just to go again, if I label this 1, 2, and 3, represent it on a number line, that's 1, that's 2, that's 3. Okay? So again, this is really important when we do the binomial distribution in statistics, and it's also important just to get the correct answer in these questions. We're looking for the overlap. Okay? That only happens here. So it only happens when x is less than -2. So that's my final answer. Okay? Hope that makes sense. So, going on to the next one. It says find the set of values of x for which x plus 5, x plus 1 is less than 32. So unfortunately we have to... The only way we can really solve this for x is if we make this side equal to 0. So we need to minus 32 from both sides. So we get x plus 5, x plus 1 is minus 32 is less than 0. So we'll start off with that. Next, we need to now refactorize this. So we need to expand the brackets. Thanks, Raid. Expand the brackets and then refactorize it. It's a bit annoying, but you know, it is what it is. X times x gives me x squared. Then I have plus 5x plus x, which would be plus 6x, plus 5 minus 32 is less than 0. So once again, plus 6x. 5 minus 32, that should be minus 27. Yep. So in terms of this, it's actually, at the moment, these topics are kind of for every single exam board. So no matter what exam board you do, you're going to be asked to do quadratic inequalities. But most of these questions are from Edexcel. Okay? But just so you know, if you went to like a CIE or OCR AQA, they would have questions exactly like this. Okay? Perfect. And then what we're looking for is two numbers that multiply to give minus 27 and add to give 6. I hope that answers your question, by the way, Raid. And if I have a think, that should be 9 and minus 3. Yep, good. So x plus 9, x minus 3 is less than 0. So once again, what we're going to do first is work out the values if it was equal to 0, as if it were equal to 0, and then add the inequality afterwards, because again, we're looking for a set of values. So either x plus 9 equals 0, or x minus 3 equals 0. So again, we're ignoring the inequality for now, but we will need to do this, need to add it back in later. So if x equals minus 9 or 3, now again, we need the inequality sign, and just like in question 1, we couldn't assume it was this, because in that case it was wrong. So what we do is we draw out the graph. So if I were to sketch this graph, the 2 points it crosses are at minus 9 and 3. And again, since it's a positive quadratic, it's going to look like that. I mean, less wonky, but it would look like that. And we're looking for the values when it's less than 0, which are all of these values here. So in other words, my answer is going to be minus 9 is less than x less than 3. Now I want you to think about, just like we did last week, the reason why it's not equal to is because if it was equal to, it would equal 0, which is not what we want. We just want less than 0, so when it's below the line. Okay? If we did less than equal to, when it equals minus 9, it's actually equal to the line, it's touching it, so it's not below it. Okay? So again, hopefully you're finding this somewhat easy at the moment, but there are some more difficult questions coming up, like things they can ask you to do. And obviously we're doing quadratic simultaneous equations as well, which can be a bit of a pain. Okay, let's move on to the next question. So solve the simultaneous equations. So if you remember back in GCSE, when you solve simultaneous equations, generally speaking, it was two linear ones that you could add or subtract or something to eliminate one of the variables. In this case, you have to use the substitution method. Okay, there's no choice, unfortunately. So what we're going to do is rearrange equation 1 and substitute into equation 2. Okay, so you can rearrange for x or y. It doesn't really make a difference. So I'm just going to rearrange for y because it makes me feel better. So that means y is equal to 3 minus x. And then I need to sub that into equation 2. Okay, so we get x squared plus 2. And now y is now, instead of 3 minus x, I'm going to write minus, actually I'll write 3 minus x just as it is to make it a bit easier. And since it's squared, we have 2 copies of the bracket. Minus 8x equals 6. So let's expand those brackets. Minus x times minus x gives me positive x squared. Minus 3x gives me minus 6. 3 times 3 is 9. Minus 8x equals 6. So far so good? Perfect. Okay. Perfect. So now we can actually expand the bracket. So we have x squared plus 2x squared minus 12x plus 18 minus 8x. And what I want to do actually as well is move this 6 over to the other side to make it minus 6 equals 0. Now we gather the like terms. X squared plus 2x squared gives me 3x squared. I like to sometimes draw a line through the ones I've already done. Minus 12x minus 8x gives me minus 20x. So again, draw a line through what I've done. Plus 18 minus 6 gives me plus 12 equals 0. And what I need to do now is factorize this to solve it. So depending on what method of factorization you like to use, what I like to do is it needs to times to AC. So that's 3 times 12, which is 36. And add to B, which is minus 20. So if you think about it, that's going to be... Again, it depends on what you really want to do with it. It's going to be 2 negative numbers anyway. So minus 18 and minus 2. Right? So we have 3x squared minus 18x minus 2x plus 12 equals 0. And yeah, it should be equals good. Factorize the first 2 terms. 3x, x minus 6. And then we need to make sure it's the same. So we need to take out minus 2, x minus 6 equals 0. It's a bit tedious, I know. 3x minus 2, x minus 6 equals 0. So our 2 solutions are going to be either 3x minus 2 equals 0 or x minus 6 equals 0. So we have x is either equal to 2/3 by adding 2 and then dividing by 3, or x is equal to 6. Oh boy! So, what we want to do now though, so the difference with quadratic simultaneous equations is I've found all of the answers for x. I now need to find all the values for y. Now, because x is squared, and it has two solutions. Now, y is squared as well, which means it has two solutions. Okay? So what I'm going to do here is I'm going to draw a dotted line going down again, or a solid line. And we're going to see what the y value is if x is 2/3, and what the y value is when x is 6. And I'm going to use the equation I wrote here, y equals 3 minus x. So y is equal to 3 minus 2/3. So that's going to be 9/3 minus 2/3. Again, you can just use a calculator, by the way, because it's a calculator exam. But it'll be that. Or you have y is equal to 3 minus 6. So y is equal to minus 3. So our four answers, just for complete clarity, is 2/3, y equals 7/3, and x equals 6, y equals minus 3. Okay? Pretty long question. They generally are 5 or 6 marks. So you need to have all four answers. You drop a mark for every answer you don't have. So be really, really careful about that. Any questions about that at all? So again, keep in mind these questions can get a bit trickier. It's not just this. They can ask you for all kinds of other wacky stuff. All good? Thank you, Ray. Perfect. Well, then let's move on. This one might not seem too tricky, but once again, we do the same thing as usual. If you're solving an inequality, you need to expand, because this is a quadratic, because we have two x's timesing each other, and then refactorize it. So if you expand that, you get x squared plus x is less than or equal to 12. So again, make sure you see the equal sign, which means we are looking for when it actually touches the x-axis, not just when it's below or above. Minus 12 from both sides. X squared plus x minus 12 less than or equal to 0. It's looking for two numbers that times to minus 12 and add to plus 1. So that would be 4 and minus 3. So x plus 4, x minus 3 less than or equal to 0. So again, now we solve it as if it's equal to 0. So either x plus 4 equals 0 or x minus 3 equals 0. So either x is equal to minus 4 or x is equal to plus 3. But again, we know it's an inequality, so we need to know how we're going to write that. Okay, so once again, we draw the quadratic. And again, it doesn't need to be like a super nice drawing. We have minus 4 here, we have 3 over here, and because it's a positive x squared, it's going to be a U shape. It'll be an N shape if it's negative x squared. We're looking for the values where it's less than or equal to, so that's going to be all of those values there. Okay? So it is equal to, and it's between those values, so it's minus 4 is less than or equal to x less than or equal to 3. And again, it's equal to because it's equal to here. So far, I'm thinking this isn't too bad. Not too bad. I think that was actually pretty quick. Okay, so here is where things get slightly more interesting. Okay, so this is, again, they can just ask you to solve inequalities like this, or solve quadratic simultaneous equations like this, but they'll probably be worth 3 or 4 marks each, and they tend to be towards the beginning of the paper. This type of question is towards the end of the paper, where it's worth 5 or 6 marks, even though you're doing the same thing, because you need to use your brain and think about what you need to use. Okay, I hope that makes sense. So I'm going to talk through the logic of this question, but again, what you can just remember is find the coordinates of the points where the circle apparently, C with equation x squared plus y squared minus 2x equals 19 meets the line L with equation that. So if it says meets or intersects, what that means is both equations are true at the same time. They're equal to each other. Okay? So the equations are equal. So x and y are equal to the x and y in the other equation as well. Okay? So all you need to know is that this is simultaneous equations. Okay? Both of those are true at the same time. That's one way you can do it. You can just memorize the fact that if they intersect or meet or cross. So let me add that word as well. Any other words I can think of? Anything that implies they're touching, then it's a simultaneous equation. You can just get on with it, okay? And that's it. So basically we're solving the simultaneous equations, y equals 3x minus 1 and x squared plus y squared minus 2x equals 19. So now it's the exact same as this question, but it's worth an extra mark because you had to make the connection that this is a simultaneous equation. Exactly, Isaac. Okay. Now, if you're okay with that, then fine. Okay. Just know that it's simultaneous. Okay. But let me show you mathematically why it's the same. Okay. So we have our xy axis. Okay. Now y equals 3x minus 1. That's going to look something like that. Okay. Now the circle, it's kind of hard for me to tell what the circle looks like other than the fact that it's a circle, but I don't know where it centers. So I'm just going to draw a circle like this. Okay. Now the points where they meet are here and here. Okay. At that point, both equations are equal to each other. So this y here is the same as this y here. And think about why. Because these y's represent coordinates, right? It's the y coordinate. At these points, can you see the x and y coordinates are the same? Right? They have to be. This point here has an x and y value, which is the same for the equation of the circle as it is for the equation of the line. It has to be. Have I convinced you that that's the case? So again, at those 2 points, they have the same coordinates, right? So both the circle and the line have the same coordinates. The coordinates are just the x and y values in both equations. So basically, both equations are the same. They're equal to each other. Perfect. So now you get an extra mark just for doing that. And now you do the exact same thing as we did back here. It's long, it's boring, but it's a pretty free 5 or 6 marks. Okay. Anything else I want to say about that? So again, if that math explanation was a bit too much or you don't care, just know that if they ever say meet, intersects, cross, whatever, it just means that you're doing simultaneous equations. So now let's solve the simultaneous. I don't need to rearrange it, so let's just do x squared plus 3x minus 1 squared minus 2x. And I'm going to move this 19 over to the other side, so minus 19 equals 0. Okay. So expand the brackets now. We have x squared plus 9x squared minus 3x gives you minus 6x. Minus 1 times minus 1 is plus 1. Minus 2x minus 19 equals 0. The next thing is just to simply collect like terms. X squared plus 9x squared is 10x squared. Minus 6x, so again I like to cross them off as I do them. Minus 6x minus 2x is minus 8x. Plus 1 minus 19 is minus 18. 0. You can choose whichever way you want to factorize this. It's a bit of a monster one. Or I can actually see... So one thing I can do to help out is all of this is divisible by 2, so I'm going to divide it by 2. I just spotted that. So minus 4x. So that makes factorizing it a bit easier. You might even be able to see what one thing is. So I know that one bracket is going to have 5x in it. And the other bracket is just going to have x. Because 5x times x is 5x squared. Then what we can think about is we need to times to minus 9 and add to minus 4. So that should be plus 1 and minus 9 because 5 plus minus 9 gives me minus 4. Yeah, that should work. Or you can again do the longer way that I showed before. If you're ever unsure, you can just do the way we did before, where we did times to AC and add to B. Okay. Either way is good. Again, make sure you check your answer, so expand this. So 5x times x gives you 5x squared. Minus 9x plus 5x gives you minus 4x. Minus 9 times plus 1 is minus 9. So we're good. All good. And again, we're going to have 4 solutions, 2 for x, 2 for y. One question, as in look at the previous question again. What I'll do is, I'm actually towards the end of the questions. I'll go back over the previous one in a second, okay? And I promise I'll go through it one more time. But I'll do that at the end of the lesson, okay? So, either we have 5x minus 9 equals 0, or x plus 1 equals 0. So we have 5x equals 9, x equals 9 over 5, bit of a pain, or we have x equals minus 1. Now again, because these are both quadratics, we have x squared and y squared, 2 answers for x, 2 answers for y. We have the 2 x answers, now we need the y answers. So what I'm going to do is sub it into this equation we had here, y equals 3x minus 1. So we have y equals, so again, if you want to continue this, 5 is 1. That gives us y equals, again, you can use a calculator because this is all calculator exams anyway. And then minus, we can make it 5 over 5 because we want it to be the same. So y is equal to 22 over 5. If that's the pair. So x equals 9 over 5. Then y equals 22 over 5. X equals minus 1. This is thankfully easier. 3 minus 1 minus 1. That gives 3 times minus 1 is minus 3. Minus 1 again is minus 4. And again, that's if x equals minus 1. Those are your 4 answers. Pretty hefty, right? But not too bad. The maths is quite easy, but it's easy to make a mistake as well. So yeah, Andrea, I'm going to go back to the previous question as soon as we finish the lesson. But you'll find it's actually pretty similar to the next few questions anyway. Give you a few seconds just to digest that. If that's all okay, we'll move on. Cool. Let's move on. Okay. Great. I get to do another one of these. So again, remember, if it says intersect, all we have to do is simultaneous equations. That's it. So I get to do another simultaneous equation. I'm very excited to hear that. But now it's saying to give coordinates, okay? So the difference here is instead of leaving my answers like this, I need to actually pair them up as coordinates. Wait, did this one? It did say coordinates. So what I'd actually do is write 9 over 5. And that's why you always read the question, by the way. Oh, that's minus 1, minus 4. Cool. I'm glad I read the question. Okay, so all we're doing is solving the simultaneous equation. So again, y is just equal to 7 minus x if I rearrange this equation. And we're going to sub it into... so do they touch each other? So by that do you mean the actual... the graphs themselves? Then they would. Instead of doing this, I want to... They would touch each other. If you, in terms of using the formula method, like the quadratic formula, you can use the quadratic formula. That is also completely valid. So that's actually a really good point that Andrea just made. To solve this expression here, I could have just said the quadratic formula. So you can use that. It's a calculator exam, so don't be afraid to use it. So since y is actually on the left-hand side, I'm actually just going to rearrange for x instead. Because we want to make sure we get a quadratic. Okay, so we have y equals 7 minus y squared minus 2x. Not 2x, sorry. 2, 7 minus y. 7. So we have y is equal to minus y times minus y is going to be y squared. Minus 7y is minus 14y. And 7 times 7 is 49. Okay, cool. Then we have minus 14. Minus 2 times minus y gives me plus 2y. Plus 7. Oh boy. And I want to move this y to the other side as well, okay? So we're going to have 0 equals. There's only one y squared, that's good. Minus 14y plus 2y is minus 12y. Minus another y will be minus 13y. Then we have minus 14 plus 7 is minus 7. And then plus 42 give me plus 42. Plus 49 will give me 42. Not understanding? Okay, no worries. So, what we want to do when these two things intersect, right, is it just means that both of these equations are true at the same time. When something happens at the same time, it means simultaneous. So all we're doing is solving these equations simultaneously. And the way you do that is you need to use elimination because it's quadratic. So all I did was rearrange for x and put it into y. And put it into the equation. Okay? So far is that okay, Andrea? Or you can tell me which line you understand up to. I think you may have joined a bit late too, so I may not have explained it as fully as I did before. Does that make sense? Okay. So, just to prove that you can use the quadratic formula, I'm just going to use the quadratic formula. Perfect. So again, you can factorize, more than happy to do that. But let's use the quadratic formula. A is the number in front of y squared, B is the number in front of y, C is the number on the end, so I'll write out the quadratic formula as well. Minus B plus or minus square root C all over 2A. So if we substitute our values in now, we have minus 13. Again, make sure you use brackets because it's very easy to make mistakes with this, especially with negative numbers. Minus 4A C and then using the power of technology, I can actually show you exactly what I'm doing on my calculator because I have online one. So we have minus 13 plus, and I start with plus just because, b squared minus 4a c over, if you spot me make a mistake, please let me know. It's possible. So we get 7 or, and again, instead of typing the whole thing again, don't forget you can use the arrow keys to edit your equation. Or 6. Well, that's pretty easy. So you can use the quadratic formula. It works perfectly fine. And now what we're going to do is... Actually, give me 1 second. I'm just going to turn on the light. There we are. Just so I look less pasty. Okay. Now what we want to do is sub it into this initial equation I had here. X is 7 minus y to find out what x is. So we have x is equal to 7 minus 7, because again it was 7 minus y. Complete the square. Completing the square, yes, that would work. You can complete the square. Might be a bit longer, but you can 100% do it. So that makes x equals 0, or x equal to 7 minus 6 equals 1. So in other words, my two coordinates are either 0, or sorry, it's not either, it's and. Yeah, you can complete the square, it's totally fine. It doesn't really change anything because you can work out values. I just think it takes a bit longer, but it's up to you. And that's it. So again, this would be a 6-mark question, which I don't think it's that bad. If you think about it, 6 marks means 6 minutes. It didn't take us 6 minutes to do it, especially if you weren't talking through it and everything. Okay. Seems like everything's fine with that, so I'm going to go to the next one. Another simultaneous equation. So we do one more just to make sure everyone is on the same page. Not that I have a choice, because I put the question in here. I have two equations. I think it's easier to rearrange equation 1 for x to be x is equal to 3 minus 2y personally. Again, it doesn't matter which one you rearrange, or well, it does matter which one you rearrange. It doesn't matter if you rearrange for y or x. Okay? And I'm going to sub it into equation 2. So we have 3 minus 2y squared plus y squared minus 2, 3 minus 2y, y equals 6. So again, I'm going to move the 6 to the other side and now expand the brackets as well. So minus 2y times minus 2y gives me 4y squared. 3 times minus 2 is minus 6y. Minus 6y again would give me minus 12y. And then plus 9 plus y squared. Minus 2 times 3 is minus 6. Then add the y. That should be a squared, by the way. Yeah. Minus 2 times minus 2 is plus 4y times y is plus 4y squared. Minus 6 equals 0. Gather the like terms. So we have 4y squared plus y squared is 5y squared plus 4y squared is 9y squared. Whoops. Minus 12y minus 6y is minus 18y. Plus 9 minus 6. So plus 9 minus 0. And again, you can divide this all by 3, so you get 3y squared minus 6y plus 1 equals 0. 3x plus 5. So, Andrea, what's that? Is that like a different question you wanted to do? And now we can just use the quadratic formula or whatever method we prefer. So, minus b, so minus 6, plus minus the square root of b squared, so minus 6 squared, minus 4a c over 2 times 3. Is that meant to be a kxy in there? Is the question to find out what k is or to find out something else? Because you need more information if they've given you a k. They have to say something about k. And what I'm going to do is go through and edit the equation I had originally. 6. So again, we did do quadratic inequalities earlier. I'm going to go through that again. Oh man, okay. This answer is correct. It's just really ugly. Okay, 0.184. I'm rounding that just to 3 significant figures. This one's going to be ugly too. 1.82, let's call it. And then to find out what x is, all you do is you sub it into the expression. So 3 minus 2 times y. So x is equal to, yeah, I don't like that. 3 minus 2, 0.184. 2.63 I'm going to call it. Or x is equal to 3 minus 2. Again, let's just... It gives me minus 0.64. There we are. Oh boy. Yes, they can give you ugly decimals, which means it's a good thing we tried the quadratic formula first, because we wouldn't have been able to factorize that. Oh, I see. Okay, so Andrea, in last week's lesson we actually did the discriminant, and you're going to have to use the discriminant for that. That's actually a really interesting question. Okay, we'll go through that. What I'll do is I'll do this inequality question just because I don't think you've seen that. And after this, I don't have any questions, so I'll do that question that you put in the chat, okay? That's a really good question. It kind of combines what we did last week and this week. You need to use the discriminant. So, first of all, solve the inequality. That should be somewhat easy, hopefully. So, for part A, all you need to do here is... Wait, let me write out the question one more time. Less than 0. And all you need to do here is factorize, right? So we want two numbers that times to minus 10 add to 3. So that would be 5 and minus 2. So we have x plus 5, x minus 2, less than 0. Okay? And what we have to think about now is we're going to solve it as if it said equals 0. So to do that, we would have x plus 5 equals 0, or x minus 2 equals 0. So that means x is minus 5, or x is positive 2. Right? Now the question is we need to now figure out which way the inequalities are going to go. Okay, so I'll go through it one more time. So it's asking us to solve this inequality here, right? So what I like to do is you can just pretend it's an equal sign. Okay? So do the same thing you'd do. Didn't understand when I was factorizing. Oh, okay. So the method that I use when I factorize is I think to myself, what numbers times to a, c, and add to b, where a is the number in front of x squared, c is the number on the end, and b is here. So AC is 1 times minus 10, so it's minus 10. And B is just 3. So what I'm looking for is two numbers that times to minus 10 and add to 3, which is 5 and minus 2, which gives me the brackets. If you have another way, you're more than welcome to do it. But this is just the way that I like to factorize things. Okay. Has that cleared that up a bit? Okay. I think that's okay now. Perfect. So to find out which side the inequality is going to lie is you just draw the graph as it would look. So I know where the x-intercepts are now. They're at x equals minus 5 and x is plus 2. And because it's a positive quadratic, we're going to draw a big U shape. And we're looking for the values that are below 0. So that's all of these values here. So our final quadratic is going to be minus 5 is less than x less than 2. And remember, if it's not less than equals in the question, then leave it as just less than, okay? Don't put an equal sign if there's no equal sign here, as in the line that goes underneath it. Oh, I see. You can do that way, but it's not the way I do it. I prefer to do it this way. But again, if you have another way that you prefer, then you're more than welcome to do it. So for part B, it says find the set of values for x which satisfy both of the inequalities. So the one we've just solved now, so this one, and another inequality here, which is 9 plus 3x. Okay, so we need to find, first of all, we need to find out what this inequality actually means. So I want the x's on one side, so since this one has more x, I'm going to subtract x. So we have 9 plus 2x less than or equal to 12. Move the 9 to the other side, so we get 2x less than or equal to 3. Divide by 2, x is less than or equal to 1.5. So what we want is both of these inequalities to be true at the same time. So I would use a number line for this. So -5, -4, -3, -2, -1, 0, 1, 2, 3. So if I call this inequality 1 and this inequality 2, number 1 just says that it's less than 1.5 and equal to, so we need to shade it in if it's equal to. And it's all the values less than it. Inequality 2 says it needs to be between -5 and 2. So the overlap is all of this stuff here. So it needs to be greater than -5, right? Greater because it's a hollow circle, but less than equal to, not 2, sorry, 1.5. And again, this is really useful when you're doing statistics as well. You have a binomial distribution, which involves, you'd have to use number lines. Or at least I highly recommend using number lines. So get good at writing inequalities on number lines. Is that all okay? Okay, so those are all the questions I had prepared, but Andrea in the chat has actually sent in another question which is really, really interesting, okay? Because it uses what we did last week as well as this week, okay? So this is like a thing. And again, this is the reason why you should join these lessons live for those of you watching later on YouTube. All it says is the straight line y equals 3x plus 5 does not meet the curve. And again, this is an exam question that comes up a decent amount. X squared minus kxy minus 3. Andrea, is there any y squared in the equation for the curve? Or is it just x squared? Can you just double check that for me? Like, is there a y squared anywhere? There is a y squared. Where would it go? So this is an actual exam question, and what you'll find is the part B is to then solve for k. So find the values of k. So it might tell you it's a positive constant or something like that, in which case you'll find out what value of k is. So there's no y squared. Okay, interesting. That actually makes it easier for us. Okay. So, this is a really good question because it comes up a fair bit in exams, okay? And it brings together a few different topics, okay? But keep in mind, there normally is a part B where you have to work out what k is. And they'll normally say something along the lines of, it might be like k is a positive constant, or k is not negative, or k is greater than 0, something like that, okay? In this case, we haven't got that part of the question, unless Andrea has it. But we're going to do the first part, which is the difficult bit. So, the straight line y equals 3x plus 5 does not meet the curve here. Now, I told you before that if it says that they meet or intersect, right, it means we can equate those two equations. We can substitute it in, right? Now, if it does not meet, it means that they're not equal to, okay? Which means if we sub in the y equals 3x plus 5 into the equation of the curve, there will be no solutions. And if you remember, that means b squared minus 4ac is less than 0, which is in the actual equation, the answer. So you have to use the discriminant. Okay? So let's get started. First of all, we substitute this in to here, knowing that there's going to be no solution. So we have x squared minus kx 3x plus 5 minus 3 equals 0. Now we're going to expand the brackets. X squared minus kx times 3x would be 3kx squared minus 5kx minus 3 equals 0. Now what I'm going to do is actually factorize out the x squared here. So we would have 1 minus 3k x squared minus 5kx minus 3 equals 0. The reason why I've done that is because the discriminant needs a, which is everything in front of x squared. It has to include both x squareds. Okay? So far so good. Again, stop me the second you don't understand. And well done to Andrea for actually stopping me when she doesn't understand. That's perfect. Keep doing that. Okay? So if I sub that into b squared minus 4ac now, I get minus 5k. Remember, it includes the k. It's everything in front of x. Minus 4. A is 1 minus 3k. C, which is minus 3. I don't know why I found that so difficult. Has to be less than 0 because no solutions. Yeah? Now again, we're showing that it equals this. We're actually pretty close, right? We're pretty close. Minus 5 squared is 25. K squared is k squared. If I bring this thing to the front, I get minus 4 times minus 3, which is plus 12. There is a reason why I'm doing it in steps. It's because it might be a bit confusing, okay? Now we expand the brackets. 25k squared plus, I'm going to do 12 times minus 3k is minus 36k plus 12 is less than 0. And if you look, that's the same as the question. So we're done. So that would be 4 marks, most likely. And you get a further 2 marks for solving the equation. Sometimes. Andrea, are you okay with that?